Hi there, I'm Joshua Finn from J&H Aerospace. Today I am wearing my flight testy hat, I guess if you will. This is the NASA N+2. We've done a video previously on the little catapult glider version that actually served as the prototype for this. So what you're about to watch is a build along, if you will. It's not a formal build video, but it includes everything you need to know for how to build this aircraft. There's a link down in the description for the thread over on the flight test forum, so you can get a little bit more information. There are some photos I've taken along the way in the build. So this is, obviously I'm recording this after she's all done. This is not just a Parkjet. This mount also fits a 24mm rocket motor, so you can fly this on Estes D12 engines. I think it will actually fly fairly nicely on the E15s, but that's not, don't do that unless you're used to going about 150 miles an hour. But the Aerotech E6 series engines will run great in this. And that's, I think, about an 8-second motor burn, so you get some time to goof around a little bit on the way up and have fun, and it'll get you way up there. So anyway, follow this, watch this video through, and you'll get to see the development of this aircraft and how to build it, and you can try your own. Come to Flight Fest, Ohio next year, and you can fly yours along with me. How's that sound? Alright, so this is the first installment in the NASA N+2 build. So what I've done is I have cut out a wing profile, and if you let it just overlap just about a 1/16 of an inch off of here, you can get the whole thing actually in one piece off of a single sheet of foam board. So I'm just going to trace this out, and then I'm going to explain some of the details. So this is a designed to be a very bare-bones, simple rocket-powered glider.
Put your pants in the bathroom.
Excuse some of the traffic in the background. We're trying to get youngins bedded down for the night, and they are being resistant about it. Oh well. Alright. So the goal here is to produce a flight test style rocket-powered glider. However, I have kind of deviated, and I'll explain how in a minute. So what I'm going to do is drop that back there, pull that lined up correctly, and we'll trace this off. We can trace out the control surfaces once we've got it cut out. There are several different ways you can build this aircraft depending on how particularly scale you want to get. I'm going to try to keep it as simple as possible, mainly because I'm limited on time these days. So, there we go. All traced out, and put us in one piece right here. That's not going to show up real well, but it's a thing. What you're going to do is get a link for the correct size nose cone, body tube. What you're going to end up doing is you're going to shave this off because the nose cone needs to angle down, kind of like that when it's installed. And we're also going to cut a slot in the top for the wing to sit down in, and we'll couple this tube to extend it out. So I'll check back in once we got it a little further along. Okay, so I have like 2 minutes to show you what I've got here. So I cut out the wings for this guy, and I cut out these doublers. There you go in here. We'll cut the dihedral brake and do all that. I'm not going to use hot glue on any of this. We're going to use Yoo-hoo pour because I needed to handle some kind of extreme conditions. These are the vertical tail surfaces. These are purely going to be for flight stabilization. They do not control the aircraft. And then the other thing I did was I set up this angle here, and the way I did it was shaved off some of the nose cone and then beveled the body tube. Now this locks in if it's like so. It will need to be permanently attached. But anyway, that's where we are for now, so I'll see you later. Okay, so what I'm going to show you here is what the state is on this N+2 rocket. So you can see we have, what we've done is this is the bottom of the wing, and these are the doublers that you install. Those make the wings stiff enough and also prevent some warps, because if you look at this, oh, how well it shows up. Yeah, you can see there's a bend to that, and it's not just the weight of the foam board. What's really frustrating is you see it goes it's hard to see, but it goes the opposite direction on that wing. So that's going to be a trim issue. And actually, I don't know if it shows up real well, but yeah. So stay put you. So this side curves up this way, and that side curves down. So that's a little bit of a trim issue as well. But anyway, everything's attached with Yoo-hoo heart, so it's a little bit flexible, a little sticky, but it works good. We set the dihedral just by setting this on top of a body tube, and you can see that sets our dihedral. And so this is fairly strong. We'll cut the control surfaces back here. We'll cut them on the bottom side. Mount servos probably next to the nacelles or something like that. And this, I mounted these fins the typical way. So you can see that. Where it got a little interesting was back here. I did not have a regular tube coupler because I stink at life. So I cut up bits of tube and made a tube coupler in there. This, basically, with the tubing in its standard shape, I cut a V-notch and I just kept wrenching it around until I got it to the taper I wanted, keeping it flat up here, which is a little bit of a pain. Wicked some CA in here, and then I've sanded it off so it's flush. We may just paint this over. I may fill it in a little bit, but nothing big there. And then up front, what we did, I don't know if you can see, we tapered the, bevel cut the end of the nose, and that worked just fine. And then, I don't know if I showed you this before, but basically I just whittled off some of that. And so now it fits in here. And the hardest part is making sure that this down angle matches where the top is back there, because you can see my mark, I'm holding this thing perfectly upright and my mark's off to the side, and that's how I set it initially, and then I had to sand the opening here to line up with that because this taper back here did not work out nearly as well as I'd hoped. But anyway, so the next thing that we're going to do is I think we're going to go ahead and we're going to just glue this nose in, and then I'll cut an electronics hatch underneath. Actually, before that, I'm going to slot the top of the tube for the wing to mount into it, and then we'll come back after I've done that. Alright, so I went ahead and I marked the top here. You can see I messed up there, but I just stuck this in up against the door frame and marked it that way. Proper way to do it is with a piece of angle iron, but I don't have one. Okay, so I keep saying I'm going to go ahead and cut these, but I went ahead and I marked it out. So what I did is I'm just estimating the width of this cut. We may have to widen it a little bit. And so I've got my center line mark, and then I've got left and right side, and then out here I've got it additional lines for the wing doublers that go on the bottom, and I've got a little bit of a taper drawn in here. So we'll after I get this cut, we'll come back, we'll test fit it and see how it works. Okay, you can see here I've cut this slot. Looks a little sketchy back here, but I'm not quite sure what happened. I may try to clean that up a little bit right there, because it is acting a little odd. But anyway, this gives us a good fit. I don't know if I can show this video real well. Okay, let's see. There we go. So that's in place, and there we go. Alright, so you can see it fits. There's a little bit of a gap right here, but not too bad. And I'm just not holding it correctly. So I'm going to tack glue this in place with CA. By the way, you can see the notch fits in there correctly. So we'll give you the dimensions for that. But yeah, that's really all there is to it. By the way, the other thing I should mention is I beveled the leading edge, the top only. You can see I stopped it there, and then I beveled the underside all the way back in, and I rounded it off slightly at the front. Same arrangement up the other side. So real simple there. So we're going to tack glue this in with CA and then fillet it with foam tack, and we'll come back. Okay, so you can see I've got hard points glued in these places, so it's a total of 6. And you can see it doesn't look real good. The waterproof foam board does not adhere real well to that. But we're going to come back with the Yoo-hoo heart, Yoo-hoo pour, and that'll take care of that problem. So we'll be back. Okay, so you can see right here I have filleted this all in with the Yoo-hoo pour. I know it doesn't look like it, but I actually closed up that gap with it. So right there, it actually has closed it up. So the nice thing about that is that means when I paint it, you won't see any of that. And so I've got the fillet, you can see, reflecting off. Now that's going to shrink down a little bit, but yeah, that'll take care of all that. So next we'll mark it out and cut control surfaces. Yeah, it doesn't show up real well, but I've got the markings for the control surface outlines and whatnot. Those are on the, if you can't tell, it's on the bottom. I also made the lines for the bottom nacelles. We'll attach those. Then we'll go on to the pylon for the top here, and we'll see how all that goes. If you can't tell, it's Christmas time here. But anyway, I got the control surfaces cut, so these have plenty of range of motion. What we're going to do is we're going to go ahead and attach these nacelles here, and then I'm going to take these, I'm going to fold them over, and I'm going to seal the hinge line with Yoo-hoo pour, just because I'm paranoid about anything peeling, and I may even do it all the way around on the edges too, because I've had some problems with that in the past. I'm paranoid. We have lots of hat tricks at our disposal, and one of them is to properly cut the ends of these body tubes. And Estes has nifty tools like this, so you can now come in here and I can just cut all the way around here and get a perfectly clean cut. I did not do that with the front of the body tube because I had to bevel it. But for the most part, check that out. Perfect cut. Okay, so we got these attached. They're held in with the Yoo-hoo pour, and the nose cone's in place, so check it out. Okay, so what we have here are the pylon core bits. Let's see, these are beveled. The outer ones are. So the way this works, we'll take the center one here, and it fits in place like so. And you can see I did the offset in the wrong spot. I must have mismeasured something, but oh well. So they fit like that. We're going to drill through the center one eventually to run wires down, so we can put an EDF or whatever we want to in here. And we'll cut a hatch somewhere underneath at some point. But for the time being, we are going to, if this will all sit correctly here. Nope, it's wanting to rock around. Come on, you stupid camera, why are you side heavy? There we go. So what we're going to do is we're going to hit this with some Yoo-hoo, and then we're going to glue it in place. There are shenanigans taking place in the background, and that's all I'm going to say about that. So, got that in place. And I'm getting kicked and kneed and all sorts of nonsense. And then my infant son is getting blamed for it. I say it's child abuse. No, not really, but okay. It's a good excuse, right? Alright, so there's the pylon. I'm going to go ahead and I'm going to attempt to mount it in place here. And then we'll set it, so we'll just glue it and we'll let it dry. And then come back to it and try to round some things off. Alright, so we're going to put glue on here. Including all the places where the glues end up not even touching. But hey. This is actually a fairly important joint long term because it's going to have about 5 pounds of thrust running through it on the D motors. When we switch over to the E6s, it'll drop down tremendously, but still. And there we go. I'm thinking I may be able to actually mount the tail here, but we'll be right back. Okay, so you can see when I put glue up top, just going to lather it on. I probably should drill that hole through here, but I'm impatient. So, who knows? I may end up running the wires externally because I'm a moron. It's kind of fun to be a moron in this case, though. So, now, I can gently rest that on there, and we'll just check it for alignment. And it's slightly crooked, but only slightly. And perfect. It's tilted though. Oh, there's the problem. That did not go well, and we're falling off. That looks about as good as I'm going to get it. So, there is where we currently are. One mean looking airplane right there. So basically at this point you're all set, and next we will make an engine mount up for it. Okay, so we did not completely finish off everything here as far as the description, so this is kind of your crash course on how to finish this plane out. So we attach these servos right here with foam tack. No biggie on any of this as far as all that. Control horns, this is just 1/32 piano wire. Figure out your best preferred way to do that, and we'll make sure we have laser files for these control horns, but flight test control horns will work. So let's see, other things we need to discuss. Yeah, so those wires route them through here. There's a hole in each side of this nacelle, and then you route in the side of the fuselage. There are better ways to do this, but this is the way I did it because I was in a hurry. You can see the same thing over here, and then setting this thing so its tail is bashing everything. Up front is where everything is located, and you're going to have to decide your preferred place for all of that. So I originally marked a spot up here, and I may cut it yet to have access to a lightweight battery that I can put up here. Right now there are a couple of 2S350s I think up here just for ballast, and then I was flying it on a 3S350. No, 300. I think it's 350. Something like that I was mounting right here. So the CG is currently right around here, so you can see where the crook of the wing is up here. You can ride it almost all the way back to the crook of the wing, and it'll be safe. It'll recover from spins and whatnot. This is the connector for your speed controller, and the receiver is... yeah, anyway, it's up in here. I've just got it riding loose. Optimally, you want to Velcro everything so it doesn't slide around. Now, the important thing for you to note is I've got the speed controller here, and the motor is back here, which means I made these extension wires. And they're also sliding loose, which is just lovely. This is a terrible idea because magnetic inductance kicks in, but if you have a good quality speed controller and a motor like this, it will work. So I can't refit those one-handed. Anyway, we're about to pull things loose regardless. So what I want to do is I want to take up some slack here so that we can slide this assembly out. Come on, you can come out of there. You can see how much this tail slides side to side. Optimally fillet this either side so it's a little stiffer. But this is our assembly for all of this. So this is a Simrock 24 millimeter motor mount set up for the BT60 body tube, and it's set up all the way up to Estes F motors, and they supply you a spacer. So like a D engine is about this long, and they supply you a spacer that goes up here, and I don't remember, actually I do remember where it is. I'll go get it. Maybe I will, because we're going to need it soon anyway. Yeah, here it is, right here. So this is a just a body tube coupler, and so I'll show you how this fits in here. We have to set all of this down and figure out. Here we go. So this assembly works out really conveniently. So you've got this. This is a retainer clip that you use for most low power rocket systems, and so this spacer slides in here and all the way up forward, and then you slide your Estes D engine in here. And if you want to fly on F motors or what have you, you remove that. What was I going to say? Aerotech. I think the Aerotech RC motors, I'll have to check. I think they fit within that context. But anyway, this is the shoulder of a BT50 24 millimeter size nose cone that I just cut off, and then I made a firewall for my motor. And I then mounted the motor on that and then just glued it in place. And so I cut this little slot for the wires, and that's convenient because there's nothing to keep this motor from sliding forward when I put it in this mount except wires sticking out the side. So when let me pop this back in here, so this thing slides in place, and then the clip slides over like so, and the wires right here keep it from sliding forward. And then once you insert all of this in here, the tape that I've got around this centering ring provides a great deal of friction, so this won't go terribly far. But that also, with those wires there, just helps a little more. Now, actually the amount of friction we have is not really optimal, so I'm going to, before I launch it on a rocket, we'll tighten that up some more. And you may, optimally, you would just go up in here, especially if you're not going to fly this on an EDF, which I found to not be possible. You would just put a tube coupler up here that's BT60 size, and you slide this assembly in, and it can't go any further forward based on that. So that's just some ways you can, there are various ways you can do this to make it work well. So basically, this is kind of the conclusion of how you build this aircraft and how you set it up to fly it. We're still going to do the rocket-powered demo of it, because I actually have not flown it under rocket power yet, so we'll do that. And from there, you're kind of on your own. I mean, ask questions as needed. We'll provide some updates as possible, and we'll provide the plans, and that'll pretty much be the conclusion of this project, and hopefully we'll fly it at Flight Fest next year. So anyway, yeah, you're going to see more footage and whatnot. So, but yeah, onward to that part. You're done with the build if you've been building along at this point.